In this session, we will delve into the basic concepts and components of fixtures in Project 1, specifically focusing on Task 1.1.2, the classification methods of fixtures. Understanding the different classification methods of fixtures helps us select and use fixtures more accurately, thereby improving processing efficiency and quality. Next, let's explore in detail the various classification methods of fixtures. Students, in machine tool processing, fixtures play a crucial role. To better understand and utilize fixtures, we need to be familiar with their classification methods. There are various ways to classify fixtures, and I will introduce them to you in detail. Classification by fixture characteristics. This is a common classification method which can be divided into general-purpose fixtures, special-purpose fixtures, general adjustable fixtures, group fixtures, modular fixtures, and traveling fixtures. General-purpose fixtures. General-purpose fixtures refer to standardized fixtures that can be used to process different workpieces within a certain range. Examples include commonly used 3-jaw chucks, 4-jaw chucks, bench vises, indexing heads, and rotary tables in machining. These general-purpose fixtures are typically produced by specialized factories and supplied to users as machine tool accessories. They are highly versatile and can be used to clamp different workpieces with little or no adjustment. The 3-jaw chuck can automatically center, making it convenient for clamping, and is suitable for clamping round and regular hexagonal workpieces. The 4-jaw chuck, on the other hand, allows for the adjustment of each of the 4 jaws individually, enabling it to clamp workpieces of various shapes. Special-purpose fixtures. Special-purpose fixtures are specifically designed and manufactured for a particular workpiece and a specific operation. Their main characteristic is their strong specificity. They are specially designed based on the shape, size, processing requirements, and the production volume of the workpiece. This ensures high processing accuracy and production efficiency. For example, in the machining of automobile engine blocks, special engine block machining fixtures are designed to ensure the positional and the dimensional accuracy of various holes. Special-purpose fixtures are typically used in production where the product is relatively stable and produced in large quantities. However, their design and manufacturing cycle is longer and the cost is higher. General adjustable fixtures and group fixtures. General adjustable fixtures refer to fixtures that can process different types and sizes of workpieces within a certain range by adjusting or replacing individual components. Group fixtures are designed based on the principles of group technology, targeting a set of workpieces that are similar in shape and have similar processing techniques. Their common feature is a certain degree of versatility and adjustability. For example, when machining a batch of shaft parts that are similar in shape but slightly different in size, a general adjustable fixture can be designed. By adjusting the positioning and the clamping elements on the fixture, it can accommodate the machining of shaft parts of different sizes. This type of fixture can reduce the number of fixtures needed, lower production costs, and improve production efficiency. Modular fixtures. Modular fixtures are fixtures assembled from a set of pre-manufactured standard elements and components. These standard elements and components come in various shapes, sizes, and functions, allowing them to be quickly assembled into the required fixture, much like building blocks. According to the machining requirements of the workpiece, the advantages of modular fixtures include high flexibility, short assembly cycles, and reusability, making them particularly suitable for the prototyping of new products and small batch production. For instance, in the aerospace industry, many components are produced in small batches or as single units, and using modular fixtures can quickly meet the machining needs of different components. Traveling fixtures. Traveling fixtures are used in automated lines or flexible manufacturing systems. They must not only position and clamp the workpiece, but also move and transport it between different workstations. For example, on an automated machining line for automobile engine blocks, traveling fixtures carry the engine block through various machining stations in sequence, completing different processing operations. The design of traveling fixtures needs to consider compatibility with the conveyor system of the automated line and the machining equipment at each workstation to ensure accurate positioning and stable clamping of the workpiece throughout the entire machining process. Classification by clamping power source. According to the different clamping power sources, fixtures can be divided into manual fixtures, pneumatic fixtures, hydraulic fixtures, pneumatic-hydraulic combined fixtures, electric fixtures, magnetic fixtures, and vacuum fixtures, among others. Manual fixtures. Manual fixtures are fixtures that achieve the clamping and release of workpieces through manual operation. They have a simple structure and low cost, making them suitable for single-piece or small batch production and the situations where the clamping force requirements are not high. For example, in bench fitting and assembly work, the commonly used manual vise is a type of manual fixture. Pneumatic fixtures. Pneumatic fixtures use compressed air as a power source to achieve the clamping and release of workpieces through pneumatic components such as cylinders. The advantages of pneumatic fixtures include quick action, faster response, and easy operation, allowing for automated control. In the welding production lines of automobile manufacturing, pneumatic fixtures are widely used for clamping workpieces to enhance production efficiency. Hydraulic fixtures. Hydraulic fixtures use hydraulic oil as a power source to achieve the clamping and release of workpieces through hydraulic components, such as hydraulic cylinders. Hydraulic fixtures provide large clamping forces, operate smoothly, and offer reliable clamping, making them suitable for situations requiring high machining precision and significant clamping force. For example, in heavy machinery processing, hydraulic fixtures are often used to clamp large workpieces. Pneumatic-hydraulic combined fixtures. Pneumatic-hydraulic combined fixtures integrate the advantages of both pneumatic and hydraulic systems, utilizing the speed of pneumatic transmission and the smooth operation and the large clamping force of hydraulic transmission. It can ensure quick action while providing sufficient clamping force, making it suitable for situations where both clamping speed and clamping force are required. Electric fixtures. Electric fixtures use electricity as a power source to achieve the clamping and release of workpieces through electric components such as motors and electromagnets. The advantages of electric fixtures include easy operation and the ability to achieve automated control, though they require an appropriate power supply. For example, in some automated processing equipment, electric fixtures are used to enhance production efficiency. Magnetic fixtures. Magnetic fixtures use magnetic force to clamp workpieces. They are suitable for workpieces made of magnetically conductive materials, such as steel. The advantages of magnetic fixtures include quick clamping and easy operation, allowing for the simultaneous clamping of multiple workpieces. For example, on surface grinding machines, electromagnetic chucks are often used as magnetic fixtures to hold workpieces. Vacuum fixtures. Vacuum fixtures use the vacuum suction generated by a vacuum pump to clamp workpieces. They are suitable for workpieces made of thin, soft, and irregularly shaped non-magnetic materials, such as plastic sheets and glass panels. In the processing of electronic components, vacuum fixtures are effective for clamping lightweight and thin circuit boards. Classification by machine tool usage. According to the type of machine tool used, fixtures can be classified into lathe fixtures, milling machine fixtures, drilling machine fixtures, boring machine fixtures, grinding machine fixtures, and gear machine fixtures, among others. Lathe fixtures. Lathe fixtures are used on lathes to clamp workpieces for turning operations. Their main function is to ensure that the rotational axis of the workpiece coincides with the axis of the lathe spindle and to achieve reliable clamping of the workpiece. Common lathe fixtures include 3-jaw chucks, 4-jaw chucks, and faceplates. For example, when turning shaft-type parts, a 3-jaw or 4-jaw chuck is typically used to clamp the workpiece. When turning complex-shaped disc parts, a faceplate may be used for clamping. Milling machine fixtures. Milling machine fixtures are used on milling machines to clamp workpieces for milling operations. Because milling involves significant cutting forces and the cutting process is discontinuous, milling machine fixtures need to have sufficient rigidity and clamping force to ensure the stability of the workpiece during processing. Common milling machine fixtures include vices, indexing heads, and rotary tables. For example, when milling flat surfaces, a vice can be used to clamp the workpiece. When milling parts that require circumferential division, an indexing head can be used for indexed clamping. Drilling machine fixtures, also known as drill jigs. These fixtures are used on drilling machines for operations such as drilling, reaming, and boring. The main function of a drill jig is to ensure that the axis of the drill bit coincides with the axis of the hole on the workpiece, thereby improving the accuracy and efficiency of hole processing. Common drill jigs include fixed drill jigs, rotary drill jigs, and flip drill jigs. For example, when processing multi-hole parts, a rotary drill jig can be used to quickly and accurately machine each hole. Boring machine fixtures, also known as boring jigs. These fixtures are used on boring machines for boring operations. The main function of a boring jig is to ensure that the axis of the boring bar coincides with the axis of the hole on the workpiece, as well as to maintain the positional accuracy between multiple holes. A boring jig typically consists of a jig frame, boring bushings, and positioning and clamping devices. When processing high-precision hole systems, a boring jig is an essential fixture. Grinding machine fixtures. Grinding machine fixtures are used on grinding machines to clamp workpieces for grinding operations. Due to the high precision requirements of grinding machine fixtures need to have high positioning and clamping accuracy. Common grinding machine fixtures include electromagnetic chucks and sine magnetic tables. For example, when grinding flat surfaces, an electromagnetic chuck can be used to quickly clamp the workpiece. When grinding parts with angular requirements, a sine magnetic table can be used to adjust the angle of the workpiece. Gear machine fixtures. Gear machine fixtures are used on gear processing machines for machining gears. Their main function is to ensure the indexing accuracy and tooth profile accuracy of the gear. Common gear machine fixtures include mandrels and centers. For example, when machining gears on a gear hobbing machine, a mandrel is typically used to clamp the workpiece to ensure the indexing accuracy of the gear. In addition to the common classification methods mentioned above, fixtures can also be categorized in other ways. For example, based on the characteristics of their use, fixtures can be divided into lathe fixtures, milling machine fixtures, drilling machine fixtures, etc. Based on the level of automation, they can be classified into manual fixtures, semi-automatic fixtures, and automatic fixtures. These classification methods divide fixtures from different perspectives, helping us to understand and use fixtures more comprehensively. The classification logic from general to specialized highlights the rigorous tradition of standardization in China's machinery industry. Just as the JBT standard system safeguards manufacturing precision, this classification method helps us establish a scientific and standardized system for the use and management of fixtures. In actual production, we can choose the appropriate fixture classification method based on different production needs and processing requirements, thereby improving production efficiency and product quality. In this lesson, we studied the classification methods of fixtures in detail. Based on the scope of use, fixtures can be classified into general fixtures, special fixtures, general adjustable fixtures, group fixtures, modular fixtures, and traveling fixtures. Based on the clamping power source, they include manual fixtures, pneumatic fixtures, hydraulic fixtures, etc. Based on the type of machine tool used, there are lathe fixtures, milling machine fixtures, drilling machine fixtures, and so on. Additionally, we learned that there are other ways to classify fixtures. By studying these classification methods, we can reasonably select and use fixtures according to different production needs and processing requirements, thereby improving production efficiency and product quality. The classification logic from general to specialized also demonstrates the rigorous tradition of standardization in China's machinery industry. I hope that in your future studies and work, you will be able to fully apply the knowledge you have learned to better master the application of fixtures